This is the OCR GCSE 9-1 Maths Paper 5 from the June 2019 series, and this paper is from the higher tier papers and it's a non-calculator paper. Question number 1. We have to work out 2 times 10 to the 3 times 4 times 10 to the 4, giving your answer in standard form. Well, just as a reminder of what a number looks like in standard form, that's when we have something of the form a times by 10 to the power of n, where a is in between 1 and 10. So we need to write the result of this in this form. If we rewrite this to begin with as 2 times by 4 times by 10 to the power of 3 times by 10 to the power of 4, well, 2 times by 4, that's 8, and you can see 8 is in between 1 and 10, and to deal with the 10 to the power of 3 times 10 to the power of 4, we'd have to use the laws of indices. That's to say, x to the power of p times x to the power of q is the same as x to the power of p plus q. When we have the same base number and we are timesing, we add the powers. Here you can see we've got the same base number of 10. We are timesing, and therefore we'd have to add the powers, and therefore 10 to the 3 times 10 to the 4, that will be 10 to the power of 3 plus 4. So what we end up with then is 8 times by 10 to the power of 7. So we have 8 times by 10 to the power of 7. Question number 2. For part A, we have to simplify fully 3a to the power of 8 times 2a to the power of 5 divided by a squared. Well, here we have to use some of the laws of indices. First of all, if we have x to the power of p times by x to the power of q, when we've got the same base and we are timesing, we add the powers. And so therefore here, x to the p times x to the q, that's x to the power of p plus q. How does this help us? Well, this allows us to simplify the numerator. 3 times by 2, that's 6. And then a to the power of 8 times a to the power of 5, that will be a to the power of 8 plus 5. And on the bottom, we've got a squared. So if we simplify the top, we have 6a to the power of 13, and on the bottom, we've got a squared. Another law of indices, if we have x to the power of p divided by x to the power of q, here, when dividing, when we have the same base, we subtract the powers, and so therefore here we'd have x to the power of p minus q. So if we tidy this up, we have 6a to the power of 13 minus 2, and therefore this will tidy up to 6a to the power of 11. We have 6a to the power of 11 as the result of this expression. And now for part B, we have to solve 6x minus 10 over 5 equals 1. Well, what we can do is get rid of the fractions, and so if we multiply both sides by 5, on the left hand side, this 5 cancels with this, leaving us with 6x minus 10, and on the right hand side, 1 times by 5 is 5. So we've got 6x minus 10 equals 5. And now if we add 10 to both sides, we have 6x equals 15, and therefore if we divide both sides by 6, then x is equal to 15 divided by 6. We can simplify this by dividing both the numerator and the denominator by 3. 15 divided by 3, that's 5. 6 divided by 3, that's 2. And therefore you can see x is equal to 5/2. Which, if you want to write that as a decimal, you can see that x is equal to 2.5. Question number 3. Ed has a card shop. He buys a particular card for £1.20 and sells it for £1.68. You have to calculate his percentage profit on this card. Well, percentage profit, that's equal to the change over the original multiplied by 100. And so therefore, what you can see then is we've got the change being 168, take away 120, and then we divide by the original 120, and then we multiply this result by 100. So 168 take away 120, that's 0.48. So we've got 0.48 divided by 120, and then we multiply this by 100. So we need to work out what is 0.48 divided by 120. Well, here, this is the same as 2/5. So what we have then is 2/5 multiplied by 100. Indeed, we end up with 40%. And so therefore, the percentage profit is 40%. And now for part B, Ed's profit on Good Luck cards in 2018 was £360. This was a decrease of 20% on his profit in 2017. We have to work out Ed's profit on Good Luck cards in 2017. Well, over here, if we have decreased by 20%, that means that 80% would correspond to £360. And we want to work out what 100% is, the profit in 2017. Well, first of all, we can find out what 10% is. And we can find out what 10% is by dividing both sides by 8. So 360 divided by 8, that's 45. So 10% would correspond to £45. And therefore, to find out what 100% is, we'd have to multiply by 10. And so therefore, 45 multiplied by 10, that's 450. So we've got £450 for the profit on Good Luck cards in 2017. Question number 4 for part A. A sunflower grows at a rate of 4 centimeters each day. How many days does it take to grow from a height of 80 centimeters to more than 1.06 meters? Well, there's a couple of ways of doing this. We can simply continuously adding on 4 centimeters to 80 centimeters until we get 1.06 meters. Now, you'd find over here we have centimeters and here we've got meters. we can make the units consistent. To go from centimeters to meters, we would have to divide by 100, and to go from meters to centimeters, we'd have to multiply by 100, and therefore 1.06 meters, if we multiply this by 100, the decimal place moves 2 units to the right, and therefore we'd have 106 centimeters. So we begin with the 80 centimeters, and if we add on 4 centimeters, we have 84, so this is 1 day. Then adding on another 4, we've got 88, then 92, then 96, then 100, then 104, and then 108. So therefore, what you can see here is it takes 1, 2, 3, 4, 5, 6, 7 days for us to reach 108 centimeters. And if we round, well, what you can see here is 106 is in between 104 and 108. So we take the next value for us to reach this value of 106 centimeters, and therefore it will take 7 days. And that's coming from counting the number of days it takes to get to 108. And for part B, if the sunflower grows at a faster rate, how would this affect your answer to part A? Well, if it grows at a faster rate, it will take quicker to reach this 106 centimeters, and therefore what we can conclude, it will take fewer days to reach the 106 centimeters. Question number 5. The table shows the ages and values of 11 cars of the same model. So we've got the age in years and the value in thousands of pounds. And the points for the first 7 cars are plotted on the scatter diagram, that's what we see here. And for part A, we have to plot the points for the remaining 4 cars. So here we've got 3 years and a value of 8. So 3, 8, that is over here. Then we have 7, 5.6, well 7, that's over here, and 5.6, well here we've got 5, and every little square is 0.2, so 5.6 is over here. Then we've got 8 and 5, 8, 5, that goes here. And then we've got 12 and 0.4. That goes here. So we've plotted the other points, and then for part B, we have to describe the type and strength of the correlation shown in the completed scatter diagram. Well, you can see here, as one quantity increases, the other decreases, and therefore we'll have a negative correlation. And the strength of that negative correlation, well, we do have a couple of outliers. We don't have points which lie on a perfect line, and therefore what we can conclude, we have a moderate negative correlation. And now for part C, one car lost its value more quickly than the other cars. On the scatter diagram, we have to draw a circle around the point representing this car. Well, that refers to the outlier over here, and this has coordinates 4 and 3.4, so it's this point over here, which is this car. Okay, and then for part D, by drawing a line of best fit, we have to estimate the value of a car that is 6 years old. So what we have to do now is draw a line of best fit. So if we grab our ruler, we want the same number of points above the line as we have below the line. So something like this will do for the line of best fit. And then at 6 years old, we have to draw a line up. So if we draw a line up, as we see here, then reading the value going across, what we have here is 6.4. So we have 6, and then if we go back, remember we have thousands of pounds, so we've got 6.4 thousand. So we've got 6.4 multiplied by 1,000, which is 6,400. So here we've got 6.4 thousand. And for party, we have to explain the limitation of using the equation of the line of best fit to estimate a car that is 16 years old. Well, what you can see over here is if we extend this line, it will eventually go negative, and we only have data going up to 12 years old. So 16 years old is outside of the data. So the age of 16 is outside the data set, and we only have data for cars up to an age of 12. Question number 6. A bag contains 4 red counters and 3 blue counters only. Jack picks a counter at random and then replaces it. He then picks a second counter at random. We have to complete the tree diagram. Well, the probability that we get a blue, that will be 1 takeaway 4/7, which is 3/7. So because he replaces, here we'd have 3/7, and here we'd also have 3/7, and here we'd have 4/7. And now for part B, we have to work out the probability that Jack picks 2 red counters. Well, we're working out the probability that he gets a red twice. So we've got here 4/7 times by 4/7. It turns out here we get 16 over 49. So therefore the probability of picking 2 red counters is 16 over 49. Question number 7. Adam buys some theatre tickets in a sale. The normal prices are £80 for each adult, £40 for each child. In the sale, the prices are reduced by 15%. Adam buys 2 adult tickets and 1 child ticket at the sale price. A 2% booking fee is then added to the total cost of the tickets. We have to calculate the total amount that Adam must pay. So what we can see here is Adam buys 2 adult tickets and 1 child ticket at the sale price. Well, what we can do is find out the sale prices for each adult and child ticket. So for the sale prices, for the adult tickets, well, we'd have to work out 15% of £80. So we have 15% off 80. Well, to do this, we have 10%, which corresponds to 8. 5% corresponds to 4. And therefore, 15% would correspond to 12. and therefore the sale price for adults, so here we have the situation for adults, we have the new price being 80 take away 12, which is £68. And if we consider the child tickets, what we have is 15% off 40. Well, 10%, that will be 4. 5% therefore is equal to 2, and therefore 15% is equal to 6, and therefore the price of a child ticket is 40 take away 6, which is 34. So therefore it costs £68 per adult ticket and £34 per child ticket, and he buys 2 adult tickets and 1 child ticket at the sale price. So therefore, for the cost, we've got 68 plus 68, so these are for the 2 adults, and then we have the 34, which is the 1 child, and therefore adding these together, 68 plus 68 plus 34, that's 170. And what we now have is 2% booking fee added. So with the booking fee, well, if we work out what 10% is, 10% of 170, that is 17. So therefore 1% is equal to 17 divided by 2, which is 1.7, and therefore 2% is equal to 3.4. So therefore we have 170 plus 3.4, which is 173.4, and therefore the cost is £173.40. Question number 8. Mrs. Mills buys 4 packs of treats for her cats, Fluff and Tigger. She gives Fluff 1/6 of a pack each day. She gives Tigger 1/5 of a pack each day. For how many complete days will the 4 packs of treats last? Well, what we can do to begin with is find out each day. So each day, we're giving 1/6 of a pack to Fluff, and we're giving 1/5 of a pack to Tigger. So each day we are giving in total 1/6 plus 1/5. And if we rewrite these over a common denominator of 30, well, to go from 6 to 30 we multiply by 5, so 1 times by 5 is 5, and to go from 5 to 30 we multiply by 6, and therefore 1 times by 6 is 6. So here we have 11 over 30. So each day she's giving 11/30ths of a pack to both cats. And we've got 4 packs, and therefore to find out how long these will last, we need to do 4 divided by 11/30ths. And so therefore, if we work this out, this is the same as 4/1 times by 30/11. So we've got 120/11. Now, to work out what this is, well, what we can do is round this value to 120/10, which is around 12. So we're expecting, rather we can round this up to 12 rather. So we're expecting around 10 days for her 4 packs to last. So therefore here we'd have 10 days. Question number 9. An interior angle of an isosceles triangle is P degrees and an exterior angle is Q degrees. It's given that Q is equal to 5P and we have to write the ratio P to Q in its simplest form. Well, what you can see here, Q is equal to 5P, so here the ratio is simply 1 to 5. For every 1 P we have 5 P's for Q. And for part B, we have to work out the two different possible sets of angles for the isosceles triangle. So, for an isosceles triangle, well, we know that the sum of the angles in a triangle equals 180. And so therefore, we've got 1 plus 5, which is 6, so we've got 6 parts. And because we've got 6 parts, we can therefore conclude that we've got 180 because we've got here the sum of angles in a triangle, and I'm going to divide this by 6. So here 180 divided by 6 is 30. So how does this help us? Well, what we can now do is conclude that P equals 30. So if P equals 30, we can have a 30 degrees and the other two angles, well, we'd have, in the first case, we'd have 30, and then the other two angles will be 180 take away 30, which is 150, and dividing that by 2, we get 75 for the other two. So we've got 30, 75, and 75. Or we can have 30 repeated twice, and in which case the other angle will be 180 take 60, which is 120. So we could have 30, 30, 120. So these are our two possible pairs, and the reason for this is the base angles on an isosceles triangle are of course equal. Question number 10 for part A, we have to write 1/6 as a recurring decimal. Well, that is simply equivalent to 0.166666, etc. So you can see that the 6 is being repeated here. So we've got 0.16 where the 6 is repeating. So here, 1/6 as a recurring decimal is shown here. And for part B, Elsa divides a 2-digit number by another 2-digit number. She gets the answer 0.15. She says that there is only one possible pair of numbers that will give this answer. Is she correct? You must show your working. Well, what we'll do is we'll convert this decimal into a fraction, and the reason we want to convert it into a fraction is because a fraction simply means divide. So what we will do is we will begin by letting x equal 0.155555, etc. And because we've got one digit repeating, 10x is equal to 1.555555, etc. So if we subtract these, then you can see 9x, that's equal to this, take away this, well, these cancel out for us. So we've got 1.5 take away 0.1, which is 1.4. And therefore, what you can see then is x is equal to 1.4 divided by 9, which is the same as 14 over 90. So what she's saying is there's only one possible pair of numbers that will give this answer. Well, she's wrong, because we also have 14 over 90, which gives this, and we also have, if we divide top and bottom by 2, we've also got 7 over 45, so therefore she's incorrect. And that's because 14 divided by 90 gives us 0.15 recurring, and also, well, over here, because what she said over here is we have a 2-digit number. So this one over here is not 2 digits. And the same thing with this. And if we unsimplify this even more, then we still wouldn't get a 2-digit number. Whereas here we do have 2-digit numbers. So this is the only possible pair we can have, 14 and 90. Question number 11, we have to simplify fully the square root of 200. Well, here we can rewrite the square root of 200 as square root 100 times by square root 2. And square root 100, that's 10, so indeed we end up with 10 root 2. And now for part B, we have to evaluate 8 to the power of a third. Well, this is the same as the cube root of 8, which is equal to 2. Question number 12. Here are two functions. We've got for function A, we have a number x, we times by 3, we then subtract 2, we get y. And for function B, we add 7 to x and then we times by 2 and we get y. And what we have to do is find an expression for the output of the inverse of function A when the input is x. Well, if we consider A, if we input x, we have x times by 3, so that's 3x. And then we subtract 2, and the result of this is y. So what we have to do is find the inverse of this. So to find the inverse, what we do is we swap the x and y. So we've got x equals 3y minus 2. We rearrange for y, and if we rearrange for y, we'd have y equals x plus 2 over 3. And therefore, we can conclude that the inverse will be, we'll call it A inverse. This is equal to x plus 2 over 3. And now for part B, here is a composite function C. We take x, we have function A, then we apply function B, and then we get z. We have to find the value of x when z is equal to 4x. So what we need to do here is actually find out our function C. So we take x and we put this into function A. Now function A, you'd find that to be 3x minus 2. And then function B, that is x plus 7 lots of 2. So we've got 2 lots of x plus 7. And then we get z. So what we do is we take function C, we put in x into it. So we start off with the x, we then input function A, so we get 3x minus 2, and then we put this into function B. So where we've got an x here, we replace it with 3x minus 2, so we would have 2 lots of 3x minus 2 plus 7. And then from here we get z. So therefore, z is equal to, well, if I tidy all of this up, we've got two lots of 3x plus 5 as z. So how does this help us? Well, we need to find out the value of x when z is equal to 4x. So when z equals 4x, we have 4x equals two lots of 3x plus 5. If I divide by 2, we have 2x equals 3x plus 5, and therefore you can find x to equal minus 5. So we have x equals minus 5. Question number 13. Shirley is asked to sketch a graph of y equals 5 to the x, where x is greater or equal to 0, and she produces the following curve. We've got two errors. How should they be corrected? Well, first of all, the curve should pass the y-axis at 1. So when x equals 0, y is equal to 5 to the power of 0, which is 1. So therefore, the first error, well, we can correct our error by making sure the curve goes through 0, 1. And the second thing is, if we have an exponential graph, and if we quickly sketch an exponential graph, something like this. So here's our axis, and then here we'd have y equals a to the power of x, and it of course crosses here at 0, 1. So therefore, the other thing that we need to correct, what we should have here is, we should have a curve with an increasing gradient. Question number 14. In the diagram, AB is parallel to CD, and AED and BEC are straight lines. We have to prove that triangle ABE is similar to the triangle CDE. Well, first of all, the angle BEA, that's this angle here, is equal to the angle CED, this angle here. So we've got this angle equaling this angle, and that's because vertically opposite angles are equal. And what else we can see is the angle DAB, that's this angle here, is equal to the angle ADC, that's this angle here. And the reason for that is we've got alternate angles. So DAB is equal to ADC, and that's because we've got alternate angles. And then we've also, for the same reason, got ABC, which is this angle here, equaling DCB, this angle here. So we've got ABC equaling DCB because we've got alternate angles. And therefore what we have over here is the angle relation, and therefore we can conclude that the triangle ABE is similar to the triangle CDE. Question number 15. OAB is a sector of a circle with centre O. OA is equal to 6 centimeters and AX is the perpendicular to OB. The area of the sector OAB is 6 pi centimeters squared, and we have to show that AX is equal to 3 root 3. Well, if we think about how we work out the area of a sector, what we have is some angle over here, we'll call it theta. We'd have here theta over 360 multiplied by pi r squared. So we've got here theta, which we don't know, and then we divide this by 360, and then we times by pi, then the radius squared, so we times by 6 squared, so we've got 36 over 360, that will be a tenth. So therefore, well, this over here is equal to 6 pi, and the reason that it's equal to 6 pi is because the area we were told is 6 pi. So we'd have here theta times by, well, the pi's cancel on both sides, and 6 squared divided by 360, that's a tenth. So we'd have theta over 10 equaling 6. Okay, just change the colour of this to red. And therefore, you'd find theta to equal 60. How does this help us? Well, we need to find out what AX is. And we can do this using trigonometry. So, here is the hypotenuse, here is the, well, AX, that is the opposite. So we've got the sine of 60 equaling opposite, which is AX, over the hypotenuse, which is 6. So we've got AX equals 6 times by sine 60. Now sine 60, that's equal to root 3 over 2. So we've got 6 lots of root 3 over 2, which is 3 root 3. And that's exactly what we wanted to show. Question number 16. A, B, C and D are points on the circumference of a circle centre O, and the angle BAD is equal to 112 and the angle CDO is equal to 33. And for part A we have to show that the angle Y is equal to 35. Give reasons for each stage of your working. Well, first of all, the angle DCB, that's equal to 180 take away 112 over here. So the angle DCB equals 180 take away this 112, which is 68. So therefore this total angle is equal to 68 degrees. And the reason for this, opposite angles in a cyclic quadrilateral sum to 180. And now what we can do is find out the angle BCO. So we can find out what this angle over here is, the angle BCO. That's therefore equal to the 68 take away the given angle of 33 here. So 68 take away 33, that's 35. So therefore here we have 35 degrees. And the reason for this, well, we don't need to give a reason, that's quite obvious, because the sum of the angles here is equal to 68. And what we can also see is if O is the centre, then over here OB is equal to OC. So OB equals OC, and that's because both of these are radii, and therefore the triangle OBC is isosceles. And therefore, to work out this angle of Y is equal to 35, and the reason for this, the base angles in an isosceles are equal. So we've got Y, which is equal to 35 degrees. And now for part B, we have to work out the size of angle Z, which is over here. Give reasons for your answer. Well, over here, we have a triangle, okay? Well, actually what we can do is work out this angle over here, the angle BOC, we can work this out to be 180 take away the 35 that we calculated, take away the other 35 that we calculated before. So here 180 take away 70 is 110. So we've got BOC equaling 110 degrees. So this angle here is 110, and the reason for that, angles in a triangle sum to 180. And now we can work out the value of Z, recognizing that angle at the circumference is half the angle at the center. So the angle Z is equal to 110 over 2, which is 55. And also, this is the result of the angle at the circumference is half the angle at the center. Question number 17. For part A, we have to write x squared plus 8x plus 3 in the form x plus a all squared minus b. Well, over here, we begin with the halving the 8, which is 4, so we've got x plus 4, and then we square this, and then we subtract off the square of 4, and then we add on 3. So we've got x plus 4 all squared minus 16 plus 3, which simplifies. We have x plus 4 all squared minus 13. And now for part B, we have to sketch this graph showing clearly any turning points on the y-intercept. Well, to work out the y-intercept, we'd have to set x equal to 0. So when x equals 0, we have y equaling 3. So it crosses the y-axis at 3, and the coordinates of the turning point, well, here we'd have minus 4, minus 13. So the graph looks something like this. We've got our turning point having coordinates minus 4, minus 3, crosses here at 3, so we've got y equals x squared plus 8x plus 3. Question number 18. 21 people travelled to a meeting, 12 used a train, 6 used a car, and 7 did not use a train or a car, and some people used a train and a car. 2 people are chosen at random from those who had used a train, and we have to find the probability that both these people also used a car. Well, the best way to approach this sort of question is to create a Venn diagram. So if we create 2 circles, as we see here, so let's just copy and paste this, and if we surround this by a box, like so, what we have is a set of people, and we've got 21 people in total, and if we call this train, and if we call this car, well, what we see over here is 7 people did not use a train or a car, so 7 goes outside over here. So let's just mark that on. We've got 7 people who did not use a train or a car. And we've got 6 in total who used a car and 12 in total who used a train. So if we call this intersection X, then we know that 12 people in total use a train. So we've got here this total equaling 12. And we've also got 6 people who used a car in total. So those who used a train only would have 12 people for all of the train, take away X who used both, so here we'd have 12 minus X, and here for the car we'd have 6 minus x. Of course, 6 people in total use a car, 12 people in total use a train. And of course here, those who used a train and a car is equal to x. So how does this help us? Well, we know then that 12 minus x plus x plus 6 minus x, all of this is equal, well, plus this 7 over here, all of this is equal to 21. The reason for that is we have 21 people who travel to the meeting in total. So we've got 21 in total here. So now if we tidy all of this up, we've got here 12 plus 6, that's 18, plus another 7, that's 25. So we've got 25, and then we've got minus x. This is equal to 21. And therefore, if we find out what x is, you can see then x is equal to 4. So with x equaling 4, we've got 4 over here, we've got 2 over here, and we've got 8 over here. Now, we have to find that both of these people, well, 2 people are chosen at random who use a train. Now the total who use a train, that will be 12. And we have to find the probability that these people also used a car. Well, we've got 12 originally, and of those 12, 4 also used a car. So this is the first person. And for the second person, we'd have 3 over 11. And therefore, what you'd find is we have 12 over 132 as the probability. Question number 19. The graph of y equals x cubed minus x squared minus 2 is drawn on the grid. That's what we see here. And we have to use the graph to solve x cubed minus x squared minus 2 equals 0. Give your answer to 1 decimal place. Well, we're looking at where the graph is equal to 0, and it's equal to 0 over here. And this point over here is equal to 1.7, and therefore x is equal to 1.7. Now for part B, the equation x cubed minus x squared plus 5x minus 6 equals 0 can be solved by finding the intersection of the graph of y equals x cubed minus x squared minus 2 and the line y equals ax plus b. We have to find the values of a and b. Well, if we compare this with what we have here, well, if we solve these two simultaneously, we'd have x cubed minus x squared minus 2 equaling ax plus b. And if we take everything to one side and set it equal to 0, we'd have x cubed minus x squared minus 2 minus ax minus b equals 0. And if we compare this with what we have over here, well, if we compare the x terms, you can see then we have a 5x over here, and the total number of x's we have here is minus a. So we've got 5 equals minus a, and therefore a is equal to minus 5. And if we compare the number terms, well, we've got minus 6 over here, and here we've got minus 2 minus b. So comparing the number terms, we've got minus 2 minus b equals minus 6. And if we multiply everything by minus 1, you can see then that b plus 2 equals 6, and therefore b is equal to 4. So we've got a equals minus 5 and b equals 4. And then we have to use the graph to solve the equation x cubed minus x squared plus 5x minus 6 equal to 0. Give your answer correct to 1 decimal place. Well, here we'd have to draw the line of y equals minus 5x plus 4. So if we go back to the graph, we need to draw that graph over here. So we need to draw the graph, let's just write this down. We need to draw y equals minus 5x plus 4. And you can see when x is 0, y is 4. And when y is equal to 0, x is equal to 5 over 4. So it intersects here at the point 4, and it intersects here at the point y equals 5 over 4, which is 1.25. So 1.25, that's over here. So now we need to draw a straight line going through those 2 points. So we've got something looking like this, and if we just make slight adjustments, we've got here the graph of y equals minus 5x plus 4. And what you can see here is it intersects at this point over here. So to find out this intersection point, we've got here the minus 1.5, so that's one solution. Well, that's just the x coordinate we want, we don't need the y coordinate. So we've got here x equals, let's just check our line. So when y is equal to 0, we've got 5x equaling 4. So if 5x equals 4, then rather here we'd have 4/5, which is 0.8. So let's just correct our line. So let's just correct our line here. Crosses at the point 4, and 4/5, which is 0.8. So we've got 0.5, 0.6, 0.7, and 0.8 goes here. So now if we draw a line through those points, let's make our adjustments. Here is our value, and if we find the x value from here, what you can hopefully see is we've got 1.1, 1.15. So we've got over here x equals 1.15, which to one decimal place is equal to 1.2.